Okay, but it was like crunching. So
Operation with radical expressions. We ready?
Yeah.
Fantastic. Now, you don't need to write this property down. You already know this property. Okay? Don't even worry about the text that's all in the box. I'm going to give you an example, okay? Square root of 2 times square root of, hold on, let me go bigger. Let me think about this. Square root of 6 times square root of 8. What's that? Square root of 48. Okay? That's all it is. That's all that property says. You multiply the insides. What if there was a number on the outside of both of them? What would you do? Multiply them too, right? Okay.
Yeah.
Numbers on the inside you multiply together. Numbers on the outside you multiply together. All right. Now that expands from just square roots to all other power roots also. Okay, and that's basically the purpose of this slide, is to say that fact. Okay. If you look down here at this part of it, you'll see cube root of 3 times cube root of 9, cube root of 27, or 3. Okay. So that multiplication property that you guys know from freshman year from up here still holds true even though you have bigger indices.
Can you do cube roots in your calculator?
Yes. Okay, I'll show you later. Everybody good? Makes sense? Okay. Now, this is your slide that's going to basically tell you things that you need to make sure are true before you circle your final answer. Okay? Because if these things are not true, you are not done. All right? First one, the index is as small as possible. 99% of the time, that's not going to be an issue. For you guys, it's probably more closer to 100% of the time. Okay? Your second one, the radicand contains no factors other than 1 that are nth powers of an integer or polynomial. I'm going to summarize that one for you guys. Factor trees. Okay? Make sure you factor tree your radicands. Okay? That's basically in smaller terms, that's what that says. Okay? You cannot have a factor other than 1 that are nth powers of an integer of a poor polynomial. For example, if you would do 48, like we just had, okay? Square root of 48. You would go 2 and 24, 2 and 12, right? That's a legal factor tree, yes? Okay? Now, and some of you would stop there because you got your pair of 2s and you put 2 red 12, but you would be wrong because there's still a power of 2 inside that 12. Okay, see what it's saying? So that 12 can still go 2 and 6, 2, 3, or faster yet, 4, 3, and then 2, 2. And there's your other pair of 2s. So basically what the second rule is saying is you must factor tree everything. Okay, makes sense? The bottom 2 we're not going to get to today, but write them down so you got them. The top 2 are basically what we're going to deal with today. Bottom 2 say the radicand contains no fractions and no radicals appear in a denominator. You've worked with examples like that in the past with square roots. It gets a little more complicated once you go to cube roots, fourth roots, fifth roots. Okay, so a little bit tougher once you go in higher indices. That's its own separate day. That's on Tuesday. All right, so first one here. Square root of 32x to the 8th. Simplify. Pretty much same deal. Just go through. Factor tree 32. So we go 2 and 16. 16 goes 4, 4. There's your 4s. So 4. And then this is where you can kind of get messy. So today these don't work perfectly all the time. Okay, so you kind of really need to be careful and really pay attention to your factor tree so you don't lose stuff, because you will. Okay, so you have 4, 4, and then you have this 2. All right, and I boxed my 2s. Okay, highlighters might be helpful. That way you don't lose stuff. Okay, so you have the 4, and then 8 is your index or your power on your variable. So divide that by 2. What do you get? 4. So we have 4 x to the 4th, and then we're left with the square root of whatever's in the box, which is 2. Done. Okay, so just a quick little refresh on how you factor tree things. Questions on that one? Everybody good? Moving along. Hey, boy. All right. What's your index this time, kiddos?
4.
4. So we need four things in our group. I can't say 4 for some reason. Okay, so you still go about it the exact same way. You still look at your factor trees, okay? So 16 goes. Let's see here. 4 and 4. Each 4 goes 2 and 2. All right? You look at that. Look there. 4 2s. Great. They come out as 1, 2. And then you go to your variables. Okay? So you always go in order. A is to the 24th power. We divide that by our index, so 4. 24 divided by 4 gives you 6. So A is to the 6th. All right, now, B. B's power is 13. 13 divided by 4 is what? 13 fourths. Let's get a decimal number this time. 3.25. Okay? That's the first time you've seen this not work out evenly. Okay? I'm going to do this for you one time. Okay? Because it's a lot of writing and it's extra writing that I don't like. B, 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 a B, a B, a B, and B. What's our index? 4. So we need 4 in our group, right? There's 1 group. There's 2 groups. There's 3 groups. 4 divides 13 evenly how many times?
3.
3. Hence the 3 groups, right? Okay, so that's your power on B. All right. What's left over?
1.
1 what?
B.
B. 1B. B to the first. Okay. B to
the second, would you have to write B to the second?
Yes, that's exactly it. Okay, so if B was to the 14th power, you'd have 2 B's left over, right?
Yeah.
So it would be B squared. Okay, if it was B to the 15th power, you'd have 3 B's left over. So it'd be B cubed. If it was B to the 16th power, you would have B to the 4th on the outside. Good. So as long as this power is lower than your index, it can be in here. So right now, this power on B is 1. That's okay. All right? That's okay. Now, if you show me this and you write this as your answer, you are losing 1 point. Does anybody know why?
Can you just circle it?
No.
Because B to the first is itself.
Still okay.
6 and 3 can be taken
Nope.
off, right? You need to include your index.
Bingo. 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 You must, and I'm serious when I say 1 point. I didn't say a half point. 1 point. Your index does not change. Okay? This is not just some random 4 you can just forget about. Because if you don't put that 4, I think you mean square roots.
Did we have to do that on the lesson check?
No, you didn't. That's why I didn't teach it to you yesterday, because you had none left over. Okay? Or you shouldn't have anyways. Okay? Your index must come along with the radical, because it's notation. It's not just a number that you forget about. Okay? Because the square root of 8 and the cube root of 8, for example, quick one, are 2 totally different things, right? Square root of 8 is 2 rad 2. Cube root of 8 is just 2. It's 2 totally different answers. You must bring your index along, no matter what. All right? Okay. Why don't you guys try those 2 right quick? Yeah, I'm going to do it. All right. All right, so factor tree 12. All right, 12 goes 4, 3. 4 goes 2, 2. Okay, there's your 2's. There's your 3 that's left over, okay? Now, your index on this one is what? 2. All right? If you want to put that in there to start and help you, that's fine. Okay? So, I mean, it's up to you on how you want to handle this. I do my outside first, so that way I can write it nice and pretty and don't have to rearrange stuff, okay? So I know I'm going to have a 2 coming out. We got C to the 6. So the power is 6, index is 2. 6 divided by 2 gives you 3. So we got 3 C's on the outside. Then we go to D's. We got 3 D's. All right, 3 divided by 2 evenly gives you what? How many times does 2 go into 3 evenly? Once, right? Okay. Did I say that weird? My bad.
Your index is 2.
Okay. Because if it's not there, it's 2. Okay, so power, so we have D to the first on the outside. Square root of. We got the 3 left over from here. And we have the 1D that we didn't get from here. Okay. Let's see your boo-boo. Alrighty. 2C cubed D square root 3D. Questions on that one? 27. This is where you can kind of, like, hopefully, you know, once you start knowing those powers and stuff. What's the cube root of 27? 3. So if you don't even want to factor tree 27 because you know the cube root of it's 3, that's cool. Alright. Y to the 12. 12 divided by 3 gives you 4, so y to the 4th. 7 divided by 3 evenly, it's what? 2, so a z squared on the inside. Radical sign, cube root of z. Yeah. Yes. Yes. You know why? I'll show you why. Okay. We're only going to do one of this, so it'd be up on the uppity up, okay? Let's make this one radical first. So multiply the outsides. So 5 times 3, 15. Okay. Now, the index is notation. So it doesn't change. Exactly. When you multiply a cube root with a cube root, it stays a cube root. Okay. It's kind of like, well, I don't know what it's kind of like, but anyways. What's 12 times 18? Anybody got that off the top of their head? Or off a calculator? 216? 216? I should, but I don't. And then we do a times a squared to give us a to the 3rd, b times b to the, or b to the 4th times b squared to give us b to the 6th. All right. So you just multiply the outsides together, multiply the insides together. Okay. Now, anything you bring out of the radical, you're going to multiply by what? 15. So I always write that first and write times before I even start factoring stuff. Okay. Now, 216 is one I want you to know, but I'm going to take a different approach this time. Okay? I'm going to take it to the side here, 216, to factor tree it. Okay? What can and what do you think, someone read my mind for me. This is what I'm asking you to do, is read my mind. What do I think your first factor tree on this one should be? Your first leaves. No, actually, not for this one.
Something that you're able to square.
Something that you can figure out very quickly without having to go back to your calculator.
16.
No.
Your inverses are the same?
Do what? What?
Your inverses are the same?
Not sure what you're saying.
I don't even know what you asked.
Okay.
8.
108.
Where did 216 come from?
18.
Oh, 12 and 8.
So go back to it. Cool? Yeah? Okay. I mean, just go back to it. Okay? Doesn't matter. Just go back straight back to where it came from. Done. Deal. There it is. Okay? So no matter how big or how ugly this number here gets, you got smaller numbers that you can straight up go to real fast. Okay? And then finish your factor trees from there. The other reason why I want to do this one this way is for this. Okay? 12 goes 4 and 3. 4 goes 2 and 2. Okay? We're looking for what here? Triples, 3. Okay? We don't have a triple yet. So you got to break down the 18. And then you have to kind of combine the two leaves. Okay? So see what we're... So 6, 3, 2, 9, whichever way you want to take. Okay? So this is also where I'm saying you might want to like take a highlighter approach to this. Okay? Because if you try to circle these 2's and then circle the 3 and go cut through like your leaf like that and make it look like that, it's going to get messy. Okay?
Can you do like 3 times 2, 3 times 2, 3 times 2?
Yeah. However you want to do your factor tree is fine, but there could be some numbers where you don't know how it's going to work out. See what I'm saying? Okay. So you have to be prepared for that. So we have 3 2's underlined in green here, right? So they come out as 1. We got 3 3's underlined in blue there. They come out as 1. And that takes care of 216.
Could you just put 6 outside to make it easy?
Okay? Does that make sense to everybody on how you get that and where that comes from? Yeah? Okay. In a minute. Yeah. But yeah. Okay. Let's do our variables first. So cube root of a cubed gives you what? A. Cube root of b to the 6 gives you? B squared. Good. And then multiply the 15, the 2, and the 3 to give you 90. Tag your variables along. AB squared. Everybody's pretty well, more or less. Yeah. Okay. It's the only thing left to do.
The ones that you can.
Which we are.
10 right 3 plus 6 right 3.
Good. Okay. Like terms with radicals. All right. Like terms with radicals. You guys know it to be the insides have to be the same, right?
Yep.
Okay. Here's what it changes to now, because you're big kids. Okay. I know. With great age comes great responsibility. Same index, same radicand. Radicand is a fancy word for your what?
What's underneath it?
Your inside, exactly. So that hasn't changed. Your index has to be the same. Okay?
So like if that was, if the 10 was like a 3, and then that one was, say, the same as 6, then here.
No, if you had like a cube root here and a square root here.
That's what I mean.
Yeah, oh, okay, then these can go together. But since and you honestly, chances are in a problem they'll all be the same root anyway, or index, so you won't have to worry about that too much. Okay, but just so you know, indexes together are the same, but they also, just like multiplication, they don't change either. Okay, they just say cube roots, fourth roots, whatever it is, right? Because these are square roots, right? We're not going to take this and make this 16 to the fourth root of 3. It's going to stay square root of 3, right? Minus 8 square root 2. That's it.
I don't know.
4 rad 3 times 3 rad 2. Multiply the outsides. 4 times 3 gives you 12. Square root 3 times 2 gives you
Oh my
6.
God, really?
Okay? Now go to the next one. 4 rad 3 times negative 6. So it's going to be a minus. 4 times 6 gives you 24 rad 3. All right? Go to your next ones. 5 rad 2 times 3 rad 2 gives you 15 rad 4. All right? Last one. 5 rad 2 times a negative 6 rad 2. All right? Now, at this point, and you'll probably have one like this on homework tonight, so be ready for it. At this point, you must do 2 things. 1, factor trees. Okay? If something factor trees, you need to take care of that because, go back to your original rules. That second one you wrote down, You must still factor tree everything no matter what type of problem you're working with. Okay? Here, we don't have a whole lot to do. We got a 6, a 3, and a 2. Can't really factor tree any of those. But you do have a what? You got the 4 on the 15. Square root of 4 is what? 2. What's 15 times 2? 30. So you need to rewrite this whole long line. Okay, yep.
Oh, so it's, which cancels out. Oh, it's just the...
Okay. And once you factor tree everything, you look for like terms. And if there's any like terms there, you combine those. Here, there's no like terms. So that's your answer.
Oh, good.
Okay? That whole 4-term long line is your answer. That's the potential for that here is high. Okay? You could have like terms in one spot, 2 spots, no spots. Okay? It just depends on the problem.